Continue extending our knowledge on quadratic functions. Okay, we've changed several of our I will statements to I can statements. I can recognize the quadratic function in vertex form. We've been doing that and identifying the vertex and axis of symmetry and all of our transformations from vertex form. I can recognize the different quadratic representations. We have our expanded form, we have our vertex form, and then we have our intercept form, okay? I can recognize the general form of a quadratic equation, the general form of the quadratic equation. I can identify the y-intercept of a quadratic function. I can solve quadratic equations by taking square roots, and the new one is I will factor quadratics by using the sum and product chart. Now, let me emphasize, today we're not actually going to complete the factoring. We are simply going to set up the sum and product chart. We're going to take it just little steps at a time. So what we're going to do is we're just going to refresh and go to some of our examples that we've done. Okay, this part 1 through 4, classify each type of quadratic function. If in standard form is also vertex form, we're going to state the vertex because the vertex is the key, is actually the, I guess what we want to say, the icing on the cake. When it's in vertex form, we can identify the vertex. If it's in expanded form is also general form, then we're going to state the y-intercept because the y-intercept is the expanded form or the general form that gives us the y-intercept. And then if it's in intercept forms are zeros, or our x-intercepts. Our x-intercepts are also our zeros and or our solutions, okay? So, number one right here, we have x minus 3, x plus 1. This is in our intercept form. It is in x, it does identify our x-intercepts. So we're gonna write intercept form. And now we're going to pay attention. It tells me, it does not tell me to state the y-intercept, or I'm sorry, not y-intercept, x-intercept. It does not tell me to state the x-intercept. It says state the zeros and or the solutions, because zeros and solutions are interchangeable as far as asking for them. So we're going to put this in solution set form. Here's my little braces. Least to greatest, P and Q. P is going to be 3. Q is going to be a negative 11 because it's opposite of what it appears. If we remember not right, it's A times X minus P times X minus Q. Okay, that is our intercept form. Okay, and like I said, our intercept form, it didn't ask me for my x-intercepts. If it asked for x-intercepts, I would put it in coordinate form. Okay, number two is also intercept form. It is intercept form, and we're supposed to state the solutions, P and Q. So here we go. We put our solution set form. P is a negative 1, Q is 4. Our A value is 3, but they didn't ask us for that, okay? So we have a negative 1 and a positive 4. So we're going to go on down to number 3. Number 3 is something we've been working with all along. Number 3 is our vertex form. Okay, remember our vertex form is A times X minus H squared plus K, where H and K are our vertex. So right here, this is vertex form. Vertex form is also known as standard form. We're going to write down both forms because we don't know which one they're going to ask for, and we have to know vertex form goes with standard form. Okay, vertex form, standard form, one and the same thing. So Now we have to do a state our vertex. Our vertex is in coordinate points, x value, x value, y value. Our x value of our vertex is h. H happens to be a -2. Our k value is a -2. Okay? Remember, for this to be a +2, h has to be negative. So we would have literally x minus a -2. That's how we get our +2, and then our k is a -2. Last but not least, we have this in expanded form, which is also called general form. So this is expanded form. Expanded form is also known as general form. And the icing on the cake on that is we can tell just from the expanded form, the general form, is our y-intercept. This parabola is going to cross the y-axis at our constant value right there. But since it is a y-intercept, it is a set of points, coordinate points. The y is a -4, and for it to be an intercept, that is always 0. So it'd be 0, -4. Okay. Now, I'm going to go back to number 1 for just a moment, and I'm going to write the things in green. We're going to pretend that it says if it is in intercept form, then state the intercepts. Okay? So we're going to pretend that it doesn't say zeros or solutions. We're going to pretend it just says state the intercepts. If I'm stating the intercepts in number 1, I have two intercepts. Okay, we have a point here and a point here. It crosses the x-axis. So one of my points is 3, and my intercept, the y, would have to be 0. The other one is a -11, and again, my intercept, in order for it to be an intercept, my y value has to be 0. So this right here would be the intercepts. Now, I know we always list things least to greatest, but when we're listing intercepts, it doesn't really matter. You can put your smallest x-intercept on the left, but truly there isn't a proper form on that one. Then on number 2, again, we're going to pretend it said state the intercepts. Again, if it's intercepts, I have a -1, 0. That's one of my intercepts. The other x-intercept is 4, 0. And again, in order to have an x-intercept, y has to be 0. In order to have a y-intercept, x has to be 0. So this is all recap, just a quick reintroduction on all of this. Now, what we're going to do, and we've done this before, okay, we're going to solve by factoring, but again, okay, we're not going to solve, we're just going to identify the sum and the product of each equation. So, this is called the sum and product chart, okay? Now, the sum and product chart, we use our values A, B, and C. We use these several times for several different reasons. Now, I do not expect you to write this down or show it in your work or whatever it isn't a requirement. This is for instructional purposes only. This is already one side equal to 0. First and foremost, factoring or completing the square or using the quadratic equation. Doesn't matter, okay? We have to get one side equal to 0. We're going to get one side equal to 0. Now, completing the square, we might not have to, okay? But when we're using the quadratic formula, or we're going to solve by factoring, which is the next 2 things that we're going to do, we are going to have one side equal to 0. So first and foremost, okay, I've done this for you all of these one side equals 0. That's exactly what we want. So since one side equal to 0, I can identify my value of A, my value of B, my value of C. Okay? Okay, so what I'm going to do, okay, my A, now I realize they use A's, N's, X's, and R's, and truly it doesn't matter. These are all quadratics. Highest exponent is a 2. So that we have a degree of 2, so therefore it is a quadratic. Now, if we remember from our previous lessons, to get it in quadratic form, it is ax squared plus bx plus c, and then we would have equal 0. One side needs to be equal 0. A is the coefficient of your quadratic term. B is the coefficient of your linear term, and C is your constant, okay? The constant is the number all by itself, but C is your constant. So what we're going to do for each one of these, because we're going to use them, we're going to use A. We're going to identify A is 3, B is a negative 16 because we keep our sign with the number, and C is a negative 12, okay? We're going to identify those. Now, is that what they asked us to do? No. They asked us to identify the sum and the product of each equation below. So, in order to identify the sum and the product, we need to identify A, B, and C. Now, eventually, we're going to actually set up a chart. The chart on the left will say sum, on the right will say product, okay? So each one of these, we're going to do A, B, and C. We're going to set up a sum and product chart for each one of those. So let's go ahead and do that. A here, A is the coefficient of our quadratic term. And again, I made sure all of these were in proper form with one side equal to 0 first. If one side is not equal to 0, we have to make that happen, okay? A is the coefficient of our quadratic term. A is 5. B is going to be a negative 16, and C is a positive 3. Again, I want to emphasize we keep the signs with the numbers, okay? We're going to have a sum and a product chart, and you're going to need to get used to doing this. We're going to do it for each one every single time. Okay, number 7, A is 2, B is a negative 9, and C is a positive 10. And I'll do my little sum and product because this is what they asked us to do, sum and product chart. Now we're going to take this a step further. We're just not going to take this step further today, okay? Here, I'm going to go ahead. I'm doing a little backwards. I got my sum here, and I got my product here, okay? So A here is 35. B here is a negative 54, and C here is a positive 16, okay? So, now that we have identified A, B, and C on each one of these, and we have our little chart, we've got to fill it in. And this, guys, this is really easy. It is so easy, okay? Your sum, what goes up here in this left-hand box, each time, every time, all the time, is your B value. Your B value on number 5 is a negative 16. So my sum here is a negative 16. That wasn't very hard. Now the product is really easy. You take the A, your quadratic term, the coefficient of your quadratic term, and you multiply it to your constant. So I'm going to take A times C. 3 times a negative 12. 3 times a negative 12 is a negative 36. That's all we're doing. That's it. That's the only new thing we're doing today. So, right here, the sum. Sum is always the coefficient of our linear term, our B value. Our B value, again, happens to be negative 16. Now, please keep in mind, it won't always be a negative 16. Okay, here it's not a negative 16. Here's not a negative 16. They just happen to be the same up here. So we have a negative 16 as the sum. The product is going to be A times C, my quadratic term times my constant. Okay, so 5 times 3 is 15. And again, that's all we're doing today. That's it. Okay, now, number 7, sum. Remember, our sum is the coefficient of our linear term. Our linear term is the term with the exponent of 1. So it is B, it is a negative 9. The product is A times C, 2 times 10. 2 times 10 is 20. Okay, quick, simple, easy. We're not down here to stress anybody out. Now these are a little bit bigger and I haven't done them off the top of my head. I do apologize. So we've got our sum, which is the coefficient of our linear term, which is our B value, which is a negative 54. Now our product is going to be 35 times 16. So 35 times 16, there's 0, there's 3, 18, there's 21, 5, and 3. So 0, 6, 5. 560. That's a very big number, but I'm going to, when we start to complete our sum and products and we actually factor, I'll show you what we're going to do with that 560. But again, that's it. That's the only new material today. You've done questions like 1 through 4. You're going to have questions like 5 through 8, okay? Quick, simple, easy. You're going to also complete this, or not, no, that's not true. You're going to solve by taking square roots. Yes, you're going to solve by taking square roots. And then, of course, we're going to do a little bit of what we did yesterday, and I'll show you guys real quick. We're actually going to get one side equal to 0, but that's it. That's all we're going to do. Like right here, okay, just like yesterday, we are going to get one side equal to 0. Now, I told you, and I want to emphasize, you are, whenever, ever, you have to manipulate any equation, any quadratic equation, you always want to try to work at where your leading coefficient, the coefficient of your quadratic term is positive. So 3a squared, that's my quadratic term, it's positive. So I'm going to add 8a to both sides, and I'm going to subtract 128. And I always do it at the same time. It doesn't really matter. On the right-hand side, I need one side equal to 0. I tend to always make the right-hand side equal to 0, but again, we have the symmetric property, so we can write it however we want it, okay? On the left-hand side, I have my quadratic term, positive 3a squared. I have my linear term was a positive 8a, and I have a minus 128. I need to emphasize these are not like terms. This is not something you can combine. We're just getting one side equal to 0. There's no terms to combine. Now that I've done that, I have to label and state the values of a, b, and c. Well, a is the coefficient of your quadratic term, which is 3. B is the coefficient of your linear term, which is 8. Remember, keep the sign with the number. And C is the coefficient, not coefficient, C is your constant. Your constant is the number all by itself, negative 128. And like I said, that's just a quick recap. Now real quick, I'll do number 13, only because it looks a little weird, and that's okay. Again, one side has to be 0, and it's not. So I'm going to add 5 on both sides. Now, 5 and 4a squared are not like terms. These are additive inverses. So I literally have 4a squared plus 5. That's it. That's as good as it gets right now. Okay? So, you need to be sure and complete the assignment, and we will check it tomorrow. Thanks for your time.